Welcome to the module on compression, limiting, and expansion. So compression is a key tool for managing the dynamic range of signals. For example, in the stage of a project where most of the creative decisions have been made and we're now optimizing it to make sure that it plays well in some particular listening environment where maybe there's a bunch of noise. And so we saw in another module that reducing the dynamic range of signals somewhat so that the quieter parts of those signals can compete better with the noise floor in a listening environment is a key consideration. And a compressor is a plugin that makes adjustments to the levels on a very quick moment-by-moment basis in an attempt to help the quieter parts compete better with the noise floor. So the basic idea is that we have a plug-in, and we give it some input audio, and whenever the average signal level of our input goes above some threshold, the threshold is set at minus 10 decibels in this example here, whenever the input level goes above that threshold, we reduce it somewhat to keep it closer to the threshold by some ratio. For example, in this diagram here, the solid line is the input level. We can see it goes this much over the threshold. And if we had a ratio of 2 to 1, that overage here gets cut in half, or in other words, the output level becomes twice as close to the threshold as it was before. Now, typically, we're using compressors in order to make the quiet parts louder, not in order to make the loud parts quieter. So in normal usage, we apply a makeup gain, and most compressors that you'll encounter in the wild will facilitate applying this makeup gain. And the idea here is that after having pushed down the things that are above the threshold, we push up everything. So here is our input signal, this solid line. So for a while it's below the threshold, and then it goes above the threshold here. And then here, this dotted line here is a representation of what we saw in the previous slides. So here's the idea of when the level goes above the threshold, it gets pushed down. And finally, this dotted line here is what we would get if after all that we pushed everything up. And so the point of this is that having push down the parts that are above the threshold, and then having pushed everything up, if we look at this and this, like the loud part and the quiet part, they're closer together than they were before. But the top is still basically in the same area it was before. So this is a very typical pattern of compression. So makeup gain, again, is gain that is applied to the signal, whether it's above the threshold or not, and it's a very, very common part of using compression. Because it's such a useful thing, compressors will typically give you the option of applying makeup gain automatically, and we'll see that in a second when we look at a compressor plugin in Reaper. And again, the purpose of all this is to allow compression, which is basically something that pushes something down, which compresses it. It's to allow it to be something that ultimately brings up the quieter parts or makes them closer to the loud parts. So it's useful to walk through some compression calculations, not because we'll ever really do these calculations in practice, but because doing the calculations is one way of ensuring that we really understand what the parameters of a typical compressor mean. So imagine that we have a compressor and it has a certain threshold and a certain ratio, and then we give it audio at a certain input level. And now our task is to figure out what the output level will be. The first question we'll ask is the input level above that threshold? If it is above the threshold, we'll ask how much it's above the threshold. And then we'll divide that amount by the ratio to get a new amount for how much it should be above the threshold. And we add that new amount above the threshold to the threshold to get the new level before makeup gain. Finally, we add any makeup gain to the new level to get the output of the compressor. So here's an example of this. We have a compressor with a threshold at minus 20 decibels full scale. The ratio is 2, and the makeup gain is plus 3. And then we present it with an input level around minus 10 decibels full scale. What is the target output level? So first we ask, is the input above the threshold? Well, minus 10 is above minus 20, so yes. How much above the threshold is it? Well, it's 10 decibels above the threshold. When we divide that by our ratio of 2 to 1, what do we get? Well, 10 decibels is going to get pushed down to be 5 decibels above the threshold. And when we add that to the threshold, we'll get our new level before makeup gain. So our threshold at minus 20, and now we add 5 decibels above that, our target level is going to be at minus 15 before makeup gain. And after we apply the makeup gain of plus 3, we're left with a final target level of minus 12. So this compressor took something that was at minus 10 and pushed it down to being at minus 12 instead. Here's another example. Compressor with a threshold at minus 10 decibels full scale, a ratio of 10 to 1, makeup gain of 4.5 decibels, and we give it an input level of around minus 5 decibels full scale, and then we ask, what is the target output level? Well, first question, is the input above the threshold? Yes, minus 5 is higher than minus 10. How much higher? Plus 5 decibels above. When we divide that by the ratio, how much should the new level be above the threshold? Well, plus 5 divided by 10 is 0.5. So we'll be 0.5 decibels above our threshold. 0.5 decibels above minus 10 is minus 9.5. Now we apply the makeup gain, which was 4.5, and we get minus 5. So minus 9.5 plus 4.5 is minus 5. So I want to call your attention here to the fact that we were above the threshold, and so compression happened, the levels got pushed down, but then because of the makeup gain, they got pushed up again, and our final output level is the same as our input level. But this is because of this particular combination of parameters. If we had basically the levels that are above the threshold are not coming up as much as the levels below the threshold. So the levels below the threshold are being pushed closer to the levels above the threshold. Compression is happening, even though we got the same answer for input and output in this particular situation. Here's example number 3. Let's say we have a compressor with a threshold at minus 50 decibels full scale, a ratio of 2 to 1, and makeup gain of plus 10. Now we give it an input level of minus 65 decibels full scale, and the question is, what is the target output level? So the first thing we ask is the input above the threshold? No, minus 65 is not above the threshold. So compression doesn't happen. And the level before makeup gain will be exactly the same as the input level, minus 65 decibels full scale. But the makeup gain is always applied to everything. So what is the level after we apply the makeup gain? It'll be minus 65 plus 10, or minus 55 decibels full scale. So let's look at the typical parameters of compression. We've already seen that ratio, in other words, how much things get pushed down when they're above the threshold, is a key parameter. And in practice, that's often the parameter that's set first, depending on the purpose for which you're using the compression plugin. And we'll come back to that in a second. We've also seen that threshold is a key parameter. That is often set experimentally or iteratively. You set the ratio that you think you need, and then you move the threshold around while listening repeatedly to the result. And typically, compression plugins will also have some key time parameters as well. Often at the very minimum, they'll have attack and release parameters. Here we see them in this Reaper plugin. And basically the idea here is that the compressor doesn't automatically go to the new target level. It goes to it over the time of the attack. And then when you come back down below the threshold with your input level, it comes back to the normal straight-through gain only after the release time has passed. If the compressor went right away to the target level, things would sound very distorted and unnatural. It would basically be like clipping the signal when it went over the threshold. But because it only gradually gets there, it's able to have a smooth effect, depending upon the relationship of these times to the kind of material that you're putting through the compressor. So often working with these 4 parameters is really kind of at the heart of working with the compressor, and then particular compressors and particular plugins will have lots of other parameters to explore and play with as well. So compression has really 3 main applications. So I think the first and most important one, it's the one that we mentioned in the other module, and so it's the one that is bringing us into this, is that compression can make it easier to hear the quieter moments within an overall finished mix. And that's certainly the main reason we're going to use a compressor in this course. We might also use it to make the quieter parts of an individual track or sound within a project louder, more punchy, more present. And there's also a special application of compression called limiting, which is really about pushing everything closer to the top in order to remove transient peaks, little individual samples that go very, very high, although we don't really notice them, in order to make the rest of our material be able to use the full detail of our digital format, of our bit depth, and then also to manage overall loudness. So depending on what our purpose for using compression is, we might have some different typical starting compression parameters. If what we're doing is gently reducing the dynamic range of an overall finished project, we'll probably start with compression ratios around 2 or less, and then we'll experiment with the threshold and time parameters. We can use relatively gentle ratios for that situation. If our purpose is rather to change the character of a particular track and make it more punchy or present, we want that voice to sound more like a radio shock jock, or that guitar to sound more metal. Maybe we're going to start with ratios between 2 or 10, and then work from there. Higher ratios, in other words. And if what we're doing is limiting, using a standard compressor, ratios between 10 and 20 would be good starting points, and fast and short attack and release times, so that all of this is happening very quickly, but not immediately still, are going to be most common. And in talking about limiting, I should also mention that you will also encounter dedicated limiter plugins. These are still basically compressors, but they have often a completely different interface, as well as some tricks that are happening in the processing in order to ensure, to be absolutely sure that the levels stay below a given maximum while not introducing any audible distortion into the resulting audio. So what I want to do now is a demonstration of how we might use a compressor to gently finalize a project. In other words, how we might use a compressor to moderately reduce the dynamic range while preserving the overall character of the sounds and while making sure that the overall peak sample is at some standard level. So the steps that we're going to follow are going to be like this. We're going to add a compressor to the master bus with a ratio of 2 to 1 or less. And by master bus here, we mean that place in the Reaper project where the plugins that you add are going to affect all of the tracks after they've been mixed together. Then we're going to work with the threshold and time parameters with automatic makeup gain on to reduce the dynamic range while preserving the character. Then we're going to turn off automatic makeup gain, measure our overall peak levels, and apply a manual makeup gain to bring our peak to the standard of minus 0.3 decibels full scale. Finally, we can listen again, and if changes emerge, we can keep the compressor on now and redo that manual makeup gain if necessary to keep the peak sample at minus 0.3. So I'm here in Reaper, and I've got a track with a short audio clip in it, and I'm going to pretend that this is a completed project. And so if this was a completed project, it would have many, many more tracks, and they would all be at different levels, and we would be experiencing the mix of all those different tracks. But it wouldn't change anything about the procedure of gently finalizing this project. So I'm going to start by going down here to Reaper's mixer where it says master. This is where all the signals from all the tracks come after they've been mixed together. And I'm going to click the effects button there on the master bus, and I'm going to add a compressor, Reaper's recomp, to it. And now this compressor, like all of the like any other plugins that I add in this chain here on the master bus, that's going to affect the sum of all the signals from all the tracks in the project. So it's in a different place and has a different function than this FX button up here on the individual track. And what I'm doing is gently finalizing this project, so I'm going to want a relatively moderate compression ratio. Let's put this at 2 for starters, although we could use smaller ratios like 1.5 or 1.2 as well. And I've got loop playback set up here. And so when I play, it's going to loop. And no compression is happening yet. I'm just going to let it loop. So before I start to work with the threshold, I'm going to turn on automatic makeup gain here. And what that's going to do is, as I move the threshold down, which is going to, as I move it down further and further, it's going to push down the higher levels more and more. Reaper is going to automatically apply a makeup gain to everything in the opposite direction, corresponding to how much I'm pushing things down, more or less. And what that means is that as I push things more and more down, it's not going to get quieter because of that automatic makeup gain. And that's going to make it easier for me to judge the impact of what I'm doing. So now I'm going to start moving the threshold down. And at a certain point, we're going to start to see this pumping red over here, which is showing us the action of the compressor. When our audio levels go above the threshold, the compressor pushes down, and then everything gets pushed up by this automatic makeup gain. And so if I was doing this for real and not as part of a quick demonstration, I'd listen repeatedly for a long time to find the perfect spot for that threshold. And I'd also work with the attack and the release parameters to see if that can give me a more natural effect, or perhaps let me move the threshold a little bit lower without the sounding distorted or unnatural, or not what we intended when we were working on the piece. So let's say then that I've done this for a while now, and I've got things where they need to be in terms of dynamic range. And now I want to make sure that my peak sample is at minus 0.3. So what I'm going to do is turn off automatic makeup gain. And the reason why I'm turning this off is that from this point forward, any adjustments to the gain are going to be completely under my control. And that means that if I have to come back and listen to this again and maybe make changes to the compression parameters, it's not going to radically change the overall level of things. And so I'll be able to make adjustments to that peak sample in the same way, again, as what I'm about to do. So if I listen through with our current settings, over here in Reaper's master bus, I will see a measurement for the peak sample after compression, and it's a bit lower than it was before. It's minus 7.2 is the highest one. So I have to add 6.9 decibels of gain to bring that up to minus 0.3, which I'm going to do just by clicking on routing and then adding 6.9 here. And now when I play from the beginning, I can hear more details than I could before, because the quieter parts are being brought up by the quick action of that compressor. And my peak sample is at minus 0.3, so I'm using the full resolution of this digital audio format while not clipping. So there's a couple of other topics to quickly talk about before finishing this module. One thing is to note that whenever we use a compressor on audio, it has an effect on the noise floor. So if this over here is our audio before compression, maybe there was a bit of noise really quietly in the signal, then there was the stuff that was quiet but which we want, and then finally there's the loud stuff. And when we use the compressor, what we're going to do is we're going to bring all of the quiet stuff closer to the loud stuff. But the point is that we're also going to simultaneously bring the noise floor, which is part of the quiet stuff, we're going to bring that up as well as part of this. And so quite commonly when you're using compressors, you'll notice this, that as you increase compression ratios, as the compression becomes more noticeable, the various electrical and digital noises in the signal, or also environmental noises, become more salient. And so this is just one more reason to be careful and try to make as low noise recordings as possible, because when we make really low noise recordings, we're going to have the potential to compress them more without that noise floor becoming audible and problematic. So I also want to talk quickly about two other plugins that are in this space, broadly speaking, which you're probably going to encounter. So one is multiband compression. This addresses a common problem with compression, which is that if we want to compress things a lot, so we have to be pretty aggressive with the ratios and the thresholds, it's often not possible to find time parameters for those settings that don't sound unnatural. So we'll get various kinds of like pumping and breathing sensations as the compressor activates and deactivates. And so one of the ways to mitigate this and make this easier is to compress different parts of the spectrum separately. And so in a multiband compressor, the input gets divided by special filters that divide it into different parts of the spectrum, like the highs, the mids, and the lows. And these are usually special filters that have been designed to work together in such a way that if you were to just filter the input and then put it all back together again, you'd get back exactly what you had in the beginning. So the filters have a special relationship to each other. But then in a multiband compressor, we take the output of all those filters and we compress them all individually, potentially with different parameters, but not necessarily. So these four compressors, they all work at different times, and then we mix the different parts of the spectrum back together again. And often it's possible to be much more aggressive in compression settings when we're working with just particular parts of the spectrum. You might also encounter expanders, which are the opposite of compressors in terms of audio plugins. So if we think about compression, as we've seen, compression works in this way. When the audio levels go above a threshold, they're pushed down to be closer to the threshold, while the levels below the threshold are unchanged, with the caveat of makeup gain. The expansion process is the opposite. When the levels are above the threshold, they're unchanged, but when they're below, they're pushed further away from the threshold. So we already saw this briefly in our module on noise strategies. That's a common use of expansion in order to take levels that are below some kind of gate threshold and push them down even further, but not pushing them away completely in order to not have that kind of on-off sensation that a noise gate has. And there are other uses for expanders and expansion as well. So to summarize this module, we looked at the basic idea of a compression plugin. We introduced its key parameters, threshold, ratio, and the times, attack and release. We looked a little bit at the difference between limiting and compression. We went through the procedure of gently finalizing audio projects to moderately reduce their dynamic range. We looked at the effects of compression on noise floor and pointed to the existence and possibility of multiband compression and expansion.